Okay, this session we're going to get an old one-tube radio from the 20s going. This set is homemade. It has a name on it of Phoenix, it looks like, A1. So this might have been originally an actual commercial set, but somebody has gone in and redone it to make it better, apparently. Okay, we have two tuning dials on it. We have a selector that goes ahead and sets the range of the tuning. When it's at the extreme, the tuning can go down to 500 kilohertz, and when it's in the middle or at the upper end, it can reach up into the short wave, up as high as 5 megahertz. Now, the regeneration is controlled by a variometer. And then we have the standard filament control for setting the gain of the tube. Connections to the radio: we have an antenna and a ground on this side, and we have our filament connections here. We have our ground and our filament, and here we have our B+. This one here is a plug-in type of phone jack for headphones, so it can actually plug into there. It also has the standard screw type terminal connections for the phones, for the headphones. Now we're going to go ahead and use the horn speaker amplifier that I built in the other video here, the last video, and we're going to use that to get it to where we can run the horn speaker with it, or at least we'll try. If it doesn't work, then I'm going to have to redo that. Okay, now inside here, okay, we have the tuning condenser, and that is just the 0 to 300 picofarad standard tuning condenser. The coil that resonates is here. It's 3 inches in diameter. It has 200 and something turns on it. I don't remember exactly the number of turns. I counted it at one point, but I have forgotten. It's 270 or 280, something like that, turns. Okay, and then taps are on there at the various points down to about half of the coil. And then our variometer is used for varying the inductance in the plate circuit, and that determines our feedback for regeneration. And then we got a standard 01A tube, and then down inside you can see we have our grid leak and our grid capacitor. Okay, and then over here we have our filament rheostat. Okay, and that's the receiver. And then this one here is the amplifier, which you can see in the other video if you want to see the way that one's built. Okay, now the schematic of the radio is pretty straightforward. Okay, we have a series resonant circuit here that's for the input circuit. So we connect the antenna onto our tuning condenser, and then between the antenna capacitance, the tuning condenser, and the coil, we can set it to any frequency from 500 kilohertz up to around 5 megahertz, a little over 5 megahertz. It almost goes to 6 megahertz. Okay, and this band switch is the switch that's on the front here. Okay, we have our grid leak and our grid capacitor, and that goes to the grid of the tube. And we have the rheostat, just a very straightforward regenerative radio circuit. And then the regeneration is the variometer, which is in the plate circuit. Now, the way that the regeneration works is there's feedback from the plate to the grid in a triode tube. Since the plate and the grid are close together, spaced in the tube, there's capacitance there. So there's capacitive coupling from the plate to the grid. So if we take and we resonate that capacitance using the regeneration control, the inductance, we can get that to be at the same frequency as the input. And when they're at the same frequency, then we can very carefully adjust it and make the phase of the signal to where it's regenerative. It adds to the input signal. Okay, and that gives us our extreme gain. Then we have our bypass capacitors to get rid of the RF in the audio part of the circuit. And that's all there is to it. It's just a very simple, basic radio. You could build one of these using a modern tube, even if you wanted to. Okay. Okay, we've got the radio power supply and the horn speaker amplifier and the horn speaker all set up. Got the antenna hooked onto it. Now, for power, we connect from the filament onto where it says minus and plus filament. Okay, that's just comes right straight from the power supply. Now, we have to be aware of which polarity we connect the B plus to. Okay, the B plus power supply has got the negative end of it, and we either connect it to A plus or to A minus. On this particular radio, it's to be connected to A plus. So we take our power supply switch and we set it to connect the common of the B plus supply onto A plus. Okay? This is built into my power supply so that I don't have to use jumpers and stuff to do that. Alright, now we take our output and we have a 5K resistor connected in place of the phones. Okay, that provides the DC path for the tube in the radio. Okay, we then take that output from the tube plate and we run over to the input of the horn speaker amplifier. The horn speaker amplifier has a capacitive input. It has a DC blocking capacitor. So we don't have to worry about our B plus feeding over into the amplifier and causing problems. Okay, we take our B plus and our filament wires and we jumper them over and we connect our B plus to B plus. We connect our A plus onto A plus and our common onto common. And that gets power between the two. And then we take our horn speaker and we connect it to the output of the horn speaker amplifier. And if all of it works properly, we will have music out of, or talk, whatever the station is, coming out of our horn speaker amplifier. Okay, let's go ahead and fire it up and see how well it works. Power is on. Aha.
Parents are busy. You're a busy person. Whether you are someone with a full-time job, maybe you're a stay-at-home mom. I know we have a bunch of stay-at-home moms that listen. No matter what, you're busy.
This is the regeneration.
Because school used to be not pro-America, at least not openly anti-America, you're not used to coming home, or your child coming home from school, and you having to be proactive.
Okay, see it. You can. It takes a little fiddling with the knobs to go ahead and get it to work. Now the amplifier. If we adjust the filament of the amplifier, that controls our gain. Okay, and also, if we adjust the filament control here, we have gain control. Okay. It takes a little bit of fiddling to get it just right. Now, we're running 45 volts on both the radio and the horn speaker amplifier. If I run it up, okay, that's 68 volts. See, what happens, it saturates the tube, so we actually get less out of it because the tube is so saturated. To use 68 volts, we'd have to lower the value of the 5K resistor so that we would not be saturating. Okay, we'll go back to 45. Okay, here's 22 volts. We can get it to work, but that's about all. Okay, we'll go back to 45. Okay, 45 volts. It's a tricky little set to keep working. Okay, so that's how we get a one-tube radio to work. Our band switch here sets which part of the band. When we're all the way clockwise on this particular radio, we can go from about 650 up to about 1200. And then if we set it to about the middle, then we're going at a higher frequency. We can go 1500, 16, 17, 50, that sort of a range. Okay? So we're using about 10 milliamps off the B plus supply and about 2 amps off of the filament supply. The majority of the current is for the 2 homemade tubes in the horn speaker amp. But it's not exactly a high fidelity set, but that's the way regenerative radios are. They have an exponential gain curve, so they sound a little bit scratchy. Okie dokie. All right. Now, that's the first one. We've got another one. We'll go ahead and get this one out of the way. We'll disconnect all the wires. Okay. Here we have our second radio that we're going to do. It's another one-tube radio. And here's the schematic of it. We have an input coil, which is a variable coil. We have an antenna switch that selects what point on the coil the antenna is connected to. And we have a ground switch that selects where you put the ground. Now this is overkill. Back in the days they made this radio, they didn't understand that putting all these switches was just kind of like ridiculous. One switch would have been completely fine, and in reality no switch at all. If they would have picked the right tap on the coil, it would have been satisfactory anyway, because you'll find that there's one particular setting of switches here that works across the entire band the best. Okay, the secondary, the movable coil, is the tuning coil. That coil along with the 360 picofarad tuning condenser, sets the frequency of the radio. This one has a variation from 550 to 1700 kilohertz. Okay, now this one has a really interesting little gizmo in it. It is a variable grid leak. And the reason they make them variable is that for a weak signal, you want a very high grid leak resistance, and for a strong signal, you want a lower resistance. So you could either have several grid leak resistors and you just pop them in and out of the little holder, or you have one of these variable jobs and you just tune that thing for the best signal. The difference in the signal will be the distortion. The sensitivity will be about the same, whether it's high, low, or whatever. But a 20 meg will give more sensitivity, but more distortion. Whereas a 500K will give less signal, but much less distortion. It may be where it actually sounds fairly good. And then we have a standard grid bypass condenser. Okay, tube 01A, standard tube. We have a 25 ohm filament rheostat that sets the gain of the tube. And then the regeneration is a variometer. It's just two coils that rotate inside of each other. And when they're in phase, you have an addition of the, or actually a multiplication of the inductance. And when they're out of phase, they cancel. I mean, the inductance can go down to very low value. It may be 10% of what it is when they're series 80. Okay, now we have another rheostat here. It's a potentiometer, actually. I have no idea what this is for. I think it was used, what you would do is you take your B battery negative and connect it onto this potentiometer, and that would set the amount of bias. I don't know. I can't tell why this would make any difference at all. It doesn't. I mean, I tried it in actual hooking it up. It makes no difference where you set this potentiometer. So this is another place where they didn't know what the heck they were doing. Okay, let's look at the radio itself. Okay, over on this side here, we have the input coil. We have all these taps going onto the switches in the front. And if we look on the front, we see we have the tuning coil, the tuning adjustment, and we have these two switches, one for the antenna and one for the ground. And when we turn the coil, we can see that the inside coil will vary between being at 90 degrees and being coaxial. When it's coaxial, we have maximum coupling between the two coils, and when they're at 90 degrees, we have minimum coupling. So we can adjust the sensitivity of the set, literally the volume, by using that adjustment. Now, there's a disadvantage to doing that, and that is that when you change the coupling of these two coils, this is the tune circuit, so any change in that coupling causes the frequency to shift. So if you change that coupling, you've got to retune it and set the thing back onto the station, peak it up. Okay, now we look right here. Look at that little gizmo. Okay, that's our variable grid leak. And we have a knob on it, and we have a cylinder that has a spring inside of it, and it's filled with carbon dust. And when you tighten this up, that spring presses on that carbon dust and causes the resistance of it to become lower. And they have it arranged in the amount of carbon dust and the spring size and all that kind of stuff to where with about 2 or 3 turns of this knob, it goes from the 500 k ohms to 20 megs. I mean, when you screw it all the way open, there's no connection at all, and the radio will stop working. Okay? This one is our tuning condenser, That's this one right here, and it's in parallel with our movable coil, and that sets the frequency that we're picking up. And then our tube. Okay, now over here, okay, we have this potentiometer up here is this odd one here that I have no idea what's for. It has no function, so it's just there. This is a home-built radio. This is not a commercial radio, so whoever built the thing had some idea for this, but he didn't know what the heck was going on. And then down inside we have the filament rheostat, and that is just a 25 ohm rheostat. Okay, and then next we have our variometer. This is the one for the regeneration. It has a inner coil. We have an inner coil. Oh my God. We have an inner coil that rotates, and then around the outer diameter, around the inside of the outer shell is another coil, and that is the fixed coil. So when this is at this position, we have the two coils crossed, so we have minimum interaction between them. When we have it in one direction, the coils add in inductance. The fields, it's just like having two layers of wire, so that the fields add, and we get 4 times the inductance that we do when we have it in the opposite direction, when the coils are bucking each other. And I've got a problem right there. You see that one right there? That inner coil is coming loose. I'm going to have to reach in there with some glue and glue that into place, because that should not come out of there like that. I don't know, I think I really need to dismantle the whole thing. But boy, you talk about a job to do. So I'm going to just take some of this glue and I'm going to slop it on there. Because the coil itself is glued together. It's just that it's come loose from the shell. So I'm just going to slop this glue on there and push it into position. Okay. And we'll just let that harden, and that'll hold that coil. Okay. Get that out of the way. Yeah. Okay. Now that'll go ahead and harden, and that'll hold that coil from coming loose like that. And if it comes loose again, I'll have to dismantle the whole thing and really go in there with a lot of glue. I don't like to use epoxy because there's sometimes you may need to repair it, and you don't want to have epoxy or you'll never be able to get it apart. All right, let's go ahead and connect the radio up and see how it operates. Okay, I've got the whole radio hooked up. It's a mess of wires all over the place, but this is just for a quick test, so yeah, it doesn't matter. Okay, let's go ahead and turn on. Okay, we get a couple amps, so this one's lighting up. We know this one's okay. All right. Now, let's see. Not getting it. That's the regeneration.
Built for business and be able to take your office with you with Windows 10 Pro. Plus, get great offers on Dell servers, monitors, docks, and more. All with easy financing options through Dell Financial Services. Call 877-ASK-DELL. That's 877-ASK-DELL. And speak to a Dell Technologies advisor today. It's 38548. Get warm out, ain't it? Kind of humid. You want to make sure that air conditioner keeps running and humming and putting out that cold?
There's another station.
Oh, that's true. So maybe, that's right. Energetics. Grab Broadway Perkinel Friday show. Now you bring us lunch. There's going to be lunch provided, yes. Really? We've got 6 pairs of tickets. Team that plays downtown on Crawford, Texas, to Houston baseball. Perfect. Wink, wink. Wink, wink. 6 pairs of tickets for you. They got the best prices. Go ahead, shop around. You'll see. And you know what? These people, solid info. You want that solid info? It really is. That's amazing. Clint Starter and the show. Ron Hughley, the only one on this show with children and family. Nick's Plumbing. Go ahead and go to nicksplumbing.com.
Okay. That one there is at 55.
Stop. I know they mean a lot.
That one's at 40.
Lord have mercy.
Well, got that full blast.
Ricky Boy and Kelly. 5 years ago today, the NWO was formed with Hulk Hogan and friends. I was just thinking about the NWO. They told me that I'll be angry. You'll say this. If David Girone's full Variometer, we'll say this. We all know that person. We have got.
Okay, here's one at 25.
That was a special. The ins and outs of Ricky.
That one comes in pretty good.
Copiosexual people are people who don't want to have sex but still have sex. Did I hear that correctly? They're sexual but they're not sexually attracted to each other. Apparently this person thought it was important to point out that communication is key. That was the last thing that she said. I don't mean it. I just did it. I'm sorry, I did it again. Wait a second. Copiosexual is just marriage. Or not. We're not. It's a long-term relationship with 2.5 kids. Never honest me.
Significant regeneration there, which means the relationship between the input and the output are not right. It seems to work best with the maximum amount of inductance. The way it's set now, we have this one at the very top and this one at the very bottom, which gives the maximum amount of signal here. And then we adjust this to get our frequency. I'm surprised there's not more regeneration. Well, just offhand, I'd say it's not much of a performer. I think the relationship between the regeneration coil and the input coil is far enough off that we don't get really good regeneration. Well, that's the second radio. Some of them work good, some of them don't. This is a home built, so you don't know. The guy just put the thing together with parts he had, and that is it. All right, that's all for that.